Hello students, how are you? Hope in good health. So let's start with new topic in chapter 5th, that is surface chemistry of 12th standard, and it is also very important topic of this chapter, that is about electrophoresis. So what we are going to talk about in this chapter, students already had studied about the charge on what, on your colloidal particles, or you can say that colloidal solutions, you can say the particle of colloidal solution are charged. Okay, so how we can just prove it, or how we can confirm it? It is confirmed by electrophoresis experiment. And now what is happening in this experiment? See, and this, colloidal solution, it is negatively charged. So when you can say that electric potential, it is applied across two platinum electrodes. Here one setup, it has been taken, you can check it out here in experiment, and two platinum electrodes are taken, and they are dipped in what? They are dipped in a colloidal solution. Fine. And this colloidal solution, it is negatively charged. So the colloidal particles, what they will start, as you know that this electric field, it is applied from outside, right? So here from the battery, the negative part of this connected here on this terminal, and you can say that positive, it would be connected here on this terminal. So what will happen, as a colloidal solution, it is present inside it, so the electric field, or the which has been, develop your electric potential, so what will it will help out to the movement of what? To the movement of colloidal particles. So what will happen, students? The negatively charged colloidal particles moves towards here your, you can just say that, positively charged, here this terminal, that is your anode. And this, this movement, the movement of this colloidal particles under this your applied, electric potential is called electrophoresis. Okay, so what will happen if your colloidal particles, it is positively charged particles, it moves towards your, if here it is present negatively charged, but if this colloidal solution, it is positively charged, so the positively particles of it move towards cathode. If it is negatively charged, your colloidal solution, then it is, you can say that it means that negative it has, so it will move towards your anode. Okay, hope this thing it is clear. So from this here in this diagram also, it this can demonstrated by this experiment setup, means that positively charged particles move towards the cathode, while negatively charged particles move towards the anode. Okay, so here this diagram, it might be asked sometimes for 2 marker in your board exam also. So draw the diagram and explain it. Once it is clear, so it would be easier for you. So this is a setup for your this electrophoresis. Okay, so when electrophoresis, what it, the movement of particles is prevented by some suitable means, it is observed that, okay, so you can stop it. It is observed that the dispersion medium begin to move in an electric field. So this, if you want to stop this, so you can done it with the help of just some kind of suitable means, okay, to stop the this I'm going to say this precipitation and this aggregation of colloidal particles. You can stop it by certain means, by adding something to it. Okay, so that time this phenomenon is known as electroosmosis. This is electrophoresis, when there is a movement of particles, movement of, charged, you can say, ions, colloidal particles towards the cathode and anode. But if you want to stop it, you have to add it something to it, and that phenomenon is known as electroosmosis. Hope it is clear. Okay, so now let's take out one more topic, that is about emulsions. Okay, yes, so what is emulsions? They are liquid and liquid, already we had studied it once in our previous session. These are, but that was only just in the form of very short definition, or you can say that in the form of simple idea. Now let's see it in detail. So what do you mean by emulsions? These are liquid colloidal system. Is it clear? Means, as you know that in colloids, what is there? One dispersed medium and another one is dispersion. But here we can say that liquid and liquid colloidal system. It means that dispersion of finely divided droplets into another liquid. If a mixture of two immiscible or partially miscible liquid is shaken, a coarse dispersion of one liquid in the other is obtained, which is called emulsions. Is it clear? When you can say that if you are taking a mixture of two immiscible, means they are not mixed together, or partially miscible, little bit, if you are shaking it. Okay, you are taking it together and you are shaking it. So a coarse dispersion of one liquid in the other is obtained, that is known as emulsion. So there are students means two types of emulsions are present. Generally, one of the two liquids is water, as it is a combination of an liquid and liquid. And if oil dispersed in water, you will say OW type. If water is dispersed in oil, you will say WO type. Okay, in the first system, water will act as a dispersion medium. Okay, and your oil will act as dispersed medium. Clear? Example of this type of emulsions are milk. Okay, you know that fats, it is present, fine. So what is that? Oil dispersed, and water, it is your dispersion medium. Even when this is your milk and vanishing cream. In milk, fat, I have told you, liquid fat, is it clear? Dispersed in water. In the second type, okay, oil, here it act as a, you can say that, act as a dispersion medium. Here you can check it out here. Oil acts as a dispersion medium and water, it acts as your dispersed medium. Examples you can talk about butter and cream. Okay, so these examples sometimes they can frame out the, the paper setters, they can frame out the MCQs from these examples. So be careful, don't get confused. Here you can check it out from this diagram, these two diagrams also, types of emulsion. See, oil in water. See here, you can check it out here. See, oil, it is your what? It is your dispersed. Oil, it is your dispersed medium. Dispersed. And here water, it is your dispersion. And when you are talking about water in oil, it would be vice versa. So students, emulsion of oil in water are unstable sometimes. They separate into two layers on standing for stabilization. See, they are unstable. Now you want to stabilize your emulsion. So what you are supposed to do, my dear students, you are supposed to add another component which is known as a emulsifying agent, or you can say a stabilizer also, isn't it? Stabilizer also, that is a stabilizing agent. Okay, emulsifying agent. See, emulsifying agents, what it is doing, it forms a interfacial film between suspended particles and the medium. Okay, you can say that it forms a one layer in between interfacial film, just in between your suspended particles, means that dispersed particle and your dispersion medium. The principal emulsifying agent, main emulsifying agent for what? For your oil to your water type, isn't it? For oil to your water type are, you can just take it out, emulsifying agent are proteins, isn't it? Gum, natural, and these are the examples, synthetic soap, etc. I mean, when you are talking about water and oil, that is a metal salts of fatty acids, long chain alcohols and lamp black, these are the examples. Okay, so be careful about your examples. See, students, now emulsions can be diluted. We can dilute it, okay, with any amount of, dispersion medium. If you want to dilute it, so what you can just with any amount of dispersion medium. On the other hand, dispersed liquid, when mixed, it forms a separate layer. Is it clear? So the droplets in emulsion are often negatively charged and can be precipitated by electrolytes. So this you had, they also show, you had just seen that Brownian movement and Tyndall effect also. Even emulsions can be broken into constituent liquids by heating, freezing and centrifugation method. Okay, hope it is clear to you. This is a very, a little easygoing but still important part from your examination point of view. And one more important topic, that is about the gold number. I'll just try to cover it in your next lecture in your class also, and I'll try to frame one small video on it. So students, take care of your health, subscribe this channel, like it and share with your just siblings or classmates or with whomever you are concerned. So bye students, have a good day, take care.